To determine the appropriate clearance for a medium voltage starter on an indoor enclosed 12 kV system using Table 110.34 of the National Electrical Code, it's essential to focus on the nominal voltage to ground as the determining factor for the voltage class. The table clearly states that the nominal voltage to ground should be used to ascertain the voltage class and subsequently the minimum required clearance. In the scenario of an indoor enclosed 12 kV system, the nominal voltage to ground is 7,200 volts, calculated as 12 kV divided by the square root of 3. This calculation is crucial because it directly influences the voltage class into which the system falls. Since 7,200 volts falls within the 2501 volts to 9,000 volts voltage class, the minimum required clearance according to Table 110.34 under condition Roman 2 is 5 feet. The definitions provided in the NEC further reinforce this interpretation. Firstly, the nominal voltage is defined as a value assigned to a circuit or system for the purpose of designating its voltage class. Secondly, the voltage to ground is defined for grounded circuits as the voltage between the given conductor and the grounded conductor, and for ungrounded circuits as the greatest voltage between the given conductor and any other conductor of the circuit. Considering these definitions, it is evident that the equipment's nameplate rating of 12 kV should not be the primary basis for determining the required clearance. Instead, the nominal voltage to ground, which is 7,200 volts, should be used. The authority having jurisdiction, or AHA inspector's interpretation, which is based on the equipment nameplate rating of 12 kV, is incorrect because it does not adhere to the NEC directive to use the nominal voltage to ground for determining the voltage class. The engineer's interpretation, which is based on the nominal voltage to ground of 7,200 volts, aligns with the NEC guidelines and is therefore the correct approach. The fact that the equipment is labeled as a medium voltage starter does not supersede the fundamental requirement to use the nominal voltage to ground for determining the appropriate clearance. In conclusion, the best way to interpret Table 110.34 in this specific scenario is to prioritize the nominal voltage to ground, which is 7,200 volts. This places the starter in the 2501 volts to 9,000 volts voltage class, thereby necessitating a 5-foot clearance as specified in the table. It is crucial to adhere to this interpretation to ensure compliance with the NEC and to maintain electrical safety standards. When working with electrical systems, especially medium voltage systems, it is essential to understand the nuances of the NEC and to apply the correct definitions and interpretations. Misinterpretations can lead to unsafe working conditions and potential violations of electrical codes. Therefore, it is recommended to consult with qualified electrical engineers and inspectors to ensure that all installations and clearances comply with the latest edition of the NEC. Furthermore, it is beneficial to stay updated on any revisions or amendments to the NEC that may affect the interpretation of specific tables or sections. Continuing education and training are vital for electrical contractors and engineers to maintain their expertise and to ensure that they are providing safe and compliant electrical installations. In summary, always use the nominal voltage to ground to determine the voltage class and adhere to the corresponding clearance requirements specified in Table 110.34 of the NEC. Remember, safety and compliance should always be the top priorities when working with electrical systems. For further clarification, it is advisable to review the specific definitions and requirements outlined in the NEC and to consult with experienced professionals in the field. The National Electrical Code is a comprehensive set of standards designed to ensure the safety of electrical installations and to protect people and property from electrical hazards. It is updated regularly to reflect advancements in technology and to address emerging safety concerns. Therefore, it is crucial to stay informed about the latest edition of the NEC and to understand its requirements thoroughly. When interpreting tables and sections of the NEC, it is essential to consider the context in which they are applied and to take into account any relevant definitions or clarifications provided in the code. In the case of Table 110.34a, the key is to focus on the nominal voltage to ground as the determining factor for the voltage class. By adhering to this principle, electrical contractors and engineers can ensure that they are providing safe and compliant electrical installations. Remember to always prioritize safety and compliance when working with electrical systems, and to consult with qualified professionals if you have any questions or concerns. Proper interpretation and application of the NEC are essential for preventing electrical accidents and for protecting people and property from electrical hazards. Understanding the difference between nominal voltage, voltage to ground, and equipment nameplate voltage is critical in this process. Nominal voltage is a designated value for a circuit or system used to conveniently classify its voltage level. Voltage to ground, for grounded systems, is the voltage between a conductor and the grounded neutral. For ungrounded systems, is the highest voltage between any conductor and another. The equipment nameplate voltage is the voltage at which the equipment is designed to operate. In the context of Table 110.34a, the NEC specifically requires using the nominal voltage to ground to determine the required working clearance. This is because the potential for electrical arcing and the associated hazards are directly related to the voltage to ground. Therefore, basing clearance requirements on this value ensures adequate protection for personnel working on or near energized equipment. The AHA role is to ensure that electrical installations comply with the NEC and local codes. While their interpretations are important, they must be consistent with the code's intent. In cases where interpretations differ, it's important to engage in open communication and to seek clarification from qualified electrical engineers or code experts. Documentation and justification for design choices are also crucial. By providing a clear rationale based on the NEC and engineering principles, contractors can effectively communicate their approach to the AHA and address any concerns. In the specific case of the 12 kV system, presenting the calculation of the nominal voltage to ground as 7,200 volts, and demonstrating that this value falls within the 2501 volts to 9,000 volts voltage class, will support the argument for a 5-foot clearance. Furthermore, referencing the NEC definitions of nominal voltage and voltage to ground will reinforce the validity of this interpretation. Ultimately, the goal is to ensure a safe and compliant electrical installation that protects personnel and property. By understanding the NEC requirements, engaging in effective communication, and providing clear documentation, electrical contractors can navigate complex code interpretations and achieve this goal. Remember that electrical safety is paramount, and adherence to the NEC is essential for minimizing the risk of electrical accident. Always prioritize safety and compliance when working with electrical systems, and never hesitate to seek guidance from qualified professionals when needed. The NEC is a living document that is constantly evolving to address new technologies and emerging safety concerns. Staying informed about the latest updates and revisions is crucial for electrical contractors and engineers. This can be achieved through continuing education, participation in industry events, and subscription to relevant publications. By staying current with the NEC, professionals can ensure that they are providing the safest and most compliant electrical installations possible. In addition to understanding the technical aspects of the NEC, it is also important to develop strong communication and problem-solving skills. This is essential for effectively interacting with AHA, engineers, and other stakeholders. By being able to clearly articulate their understanding of the code and to address concerns in a professional manner, electrical contractors can build trust and foster positive working relationships. Ultimately, the success of any electrical project depends on a collaborative effort among all parties involved. By working together and adhering to the NEC, we can create safer and more reliable electrical systems for everyone. So, in the case of the 12 kV system, remember to focus on the nominal voltage to ground, which is 7,200 volts, and to advocate for a 5-foot clearance based on the NEC requirements. With clear communication, thorough documentation, and a commitment to safety, you can successfully navigate this code interpretation and ensure a compliant installation. And always remember, when in doubt, consult with a qualified electrical engineer or code expert. Their expertise can provide valuable guidance and ensure that your electrical installations meet the highest standards of safety and compliance. Electrical safety is not just a matter of following the code, it is a commitment to protecting lives and property. By prioritizing safety in every aspect of our work, we can create a safer and more sustainable future for all. This is why understanding and applying the NEC is so crucial for everyone involved in the electrical industry. The correct interpretation of the NEC directly influences the safety and functionality of electrical systems. Clear and precise adherence to these standards is not merely a regulatory requirement, but a fundamental aspect of responsible engineering and contracting. The NEC, therefore, should be regarded as a primary resource and guide, ensuring that every electrical installation meets the highest standards of safety and efficiency. Remember, an informed and cautious approach is the best defense against potential electrical hazards, benefiting both the professionals working on the systems and the end users who depend on their reliability.